Thank you very much. Andrew, thanks for inviting us to do this. How things have changed, like we mentioned on the panel, at a crusty old mining engineer that's been out. Why do you become a mining engineer? Well, they give you explosives and you get to blow stuff up. That's the main reason. So here we are in a renewable energy conference, and it just shows you where our industry is really headed. This is the second project for B2 Gold. We did a solar plant at our Otjikoto mine a number of years ago, which was quite successful, and we're off and doing this one. Oops. There we go. This is the cover your behind slide that tells you that halfway through the talk, if you guys all want to run out and buy a whole bunch of our stock, you really can't rely on the forward statements I'm about to make in this presentation. But go buy that stock anyhow. A little bit about B2 Gold. We are scattered quite around the world. Our corporate office in Vancouver. Our operating mines are in Mali, West Africa, the Fekola mine. That's the one we'll be talking about today. Otjikoto mine in Namibia, and our Masbate mine in the Philippines. We also have projects we're working on in Burkina Faso, and we have an advanced development project that we're working on with AngloGold in Colombia. A little bit more about the company. We're roughly 11 years old. We got started in early 2007, so almost 12 years old now. We've got started in Nicaragua, and we've had a very successful ramp up here. We hope to be right in that million ounce range next year. So we just keep adding projects and expanding our current projects, which is our focus right now. And that brings us to Fekola, which is our main, that's our flagship property. And we're looking at, we're actually expanding the plant right now. We're expanding the mining fleet to mine more tons faster. We've done a tremendous amount of exploration to expand the resources there. That's why we're doing all of this. And so that was one of the reasons we really wanted to look at our power supply and what can we do to augment that and not add more engines, but let's add some renewable energy to do this thing. This is kind of the ramp up at Fekola. We bought the project from a company called Papillon, and we did that in 2014. And so we did the permitting, the feasibility studies and everything to get this going. Originally it was going to be 4 million tons a year. While we were building it, we kept drilling and we found out that, well, oops, there's probably a lot more ore here than we think there is. So let's use our design factor of 20% and let's go ahead and expand a few things and let's come out the gate at 5 million tons a year. So we did that. So when we actually started this thing up in September of 2017, so when we did the first production, we were actually at a rate of 5 million tons. We then did a bunch of optimizations in the plant and got it up closer to 6 million tons while we were doing a study to say how big can we go with this thing. And we've determined that should be a nominal rate of 7.5 million tons. And we're in the process of doing that conversion right now. We can get that much through our existing mills by just adding some more horsepower, bigger drives, things like that, and take this thing up to 7.5 million tons a year. To do that, we're going to consume about 40 megawatts of power a year. So that brings us to what we're talking about today, which is the solar. What do we do? What do we do to move that forward? How do we keep that bigger, more powerful mills and bigger plant running here? The existing power plant that we built was probably oversized a bit, which was fortunate because of all the immediate ramp-ups we did. We have a Caterpillar plant there. We have 8 16 CM32 engines. And then we have 4 smaller diesel engines just to help balance loads. So roughly 64 megawatts of power installed out there through HFO and a little bit of diesel. We run the diesel engines almost not at all. For 40 megawatts of power, we got to run 6 of these engines to produce that long term, which still gives us a +2 scenario. So you've got 2 engines, one to do service on, one to do overhauls on. But it's pushing that plant pretty hard, especially when it gets hot. We hit 50 degrees C out there, and the capacity of these engines drops off quite a bit. So we commissioned a study with SunTrace, and I'd like to introduce Martin and Lucas are sitting here in the front row. You guys raise your hands. There was SunTrace out of Hamburg, Germany. They did all the initial work for us on us when we started looking at this, and we said, what do we want to build? So we're not solar guys, we're not wind guys, we're not anything. We're mining engineers. We know how to dig up rock and get the gold out of it and do that quite efficiently. But something like a solar plant is really not our expertise, and that's why we went to a group of experts here to really help us out on this. So we looked at everything. How big a plant should we build? We looked from 10 to 30 megawatts, and I think we even looked at a little bit bigger at one point in time. We looked at all the available technologies, all the different batteries that are out there, all the different solar panels that are out there. We looked at all the different tracking systems. Should these be fixed panels, single axis, double axis panels? What's the most efficient? What's the biggest bang for the buck? How should this thing be designed on the terrain that we have? How far should the strings be apart? How much distance between panels? How many panels go on a single inverter? How can we design the most efficient plant possible, and then all the economic ramifications that come with that? What does this mean for us? What's the payback on this plant? What savings can we expect, et cetera? All came out of these feasibility studies. So that's basically what we completed there. Oops, there we go. So we settled in on a 30 megawatt solar plant, which is a fairly large undertaking. We are, and by the way, the first presentation you saw this morning, they talked about getting off the grid. We don't have that problem. We were never on a grid. At Masbate, at Otjikoto, and here at Fekola, we are not on the grid at all. Here at Fekola, we're a couple hundred kilometers from the nearest power lines, which does not have a lot of excess capacity on it. So getting on the grid here was never an option for us. We looked at, when we started up Fekola, we looked at a whole different number of scenarios. The only one that we could build fast enough to make our startup time was basically running engines and HFO/diesel plants to get this thing going. So that's what we did here. But for the solar plant, again, we settled in on a 30 megawatt plant, single axis tracking system, which means the panels just tip back and forth. They don't move side to side. Things of that nature. We've gone with the crystalline type panels. This plant covers about 70 hectares, which is 700,000 square meters. So it's not a small plant by any means in the final design here. We've gone with the lithium alloy batteries. They're just more, they give you the flexibility, they react quickly to pick up loads, and we'll talk a little bit more about the batteries as we go on here, but the batteries are kind of the key to the economics here. It allows you to keep your engines shut off. It allows you to shut them down a little quicker, start them a little later. It takes out all the power surges, and it really, really smooths out the whole operation. So the integration system between solar, batteries, engines, et cetera, was a real key component and part of the main engineering function on making sure this thing's going to run right. Also, the forecasting system. We're using satellite forecasting, and we're also using sky monitoring. Sky monitoring is for short-term clouds that come through. The solar is for longer term. If we got a big storm that's going to cover us up all day long, the operators need to know that. Engines need to stay online. There's things we won't shut down. We'll run more engines, produce less PV, and still have, what we do not want is we do not want those mills to shut down because we have a shortage of power at any point in time in our operations. That's how we make our money, is for those mills to be running 24 hours a day. So that was one of the key requirements here. The solar plant itself, this is kind of a layout here that you can see. We were able to put it right in against the the current power plant that we have. Up near the top in the center there, you see kind of a blue square there. That's our existing power plant, so that's where our control centers are and everything there. So we're just across the road from it, so it's not a remote plant. And also for security reasons, we just extend our fence out around this thing too, and we'll keep it within our secured area there, which is a key in West Africa. Solar panels seem to be popular. They tend to sprout these little legs and crawl off if you don't take care of them there. So it's one of the key things to do there. We're using a string inverter concept, so X amount of panels per string inverter on that. We've tried to optimize the layout here on the terrain we have for the cut and fills, and then of course to absorb the maximum amount of PV possible also with the designs and the situation of it. The reason there's gaps and stuff in the layout there is simply that's what the terrain is, because of steepness of terrain, little valleys, things of that nature. We're doing, it's all been designed for drainage and access, everything else here also. So that's what we're going with that. And this area now has been completely cleared and grubbed, and we're getting ready to actually start construction on site as we speak. So we're moving this well along here. The panels have been, Canadian Solar is the company that's going to supply all of our panels to us. So we did get a good Canadian company in there, helping, even though the panels do come from China. Okay, we all know that. Oops, I got ahead of myself there. Yeah, the modules themselves are the monocrystalline type models. Fairly standard, and nothing earth-shattering here. We did some work on site. We set up a weather station on site. We actually monitored, we compared what we were actually measuring as far as PV, how much PV radiation we could absorb at the weather station. We compared that to all the satellite statistics and stuff, so we could calibrate what we really thought we would get out of this plant. We also did some cleaning exercises where we cleaned some panels like every day. We cleaned others once a month, and we didn't clean some of the panels at all. We found that the dust, it could be a very dusty area for a couple months of the year. We were really worried about that for our solar. We find out that the dust we have, let's say it's not a clingy type of dust. It tends to come off of the panels by itself. The panels we did not clean performed very, very close to the panels that we did clean, which was a big benefit. It was something we were extremely worried about at one point in time, and it's just not a big deal. The tracker systems, which was key to this, are being, as you can see, we've got, when we talk about how many panels are we putting up, well, we've got almost 93,000 panels. So that's a lot of truckloads of panels. This is, again, a 30 megawatt plant. I believe, and you guys correct me if this is wrong, but if this isn't the largest off-grid hybrid plant, it's one of the very largest in the world. So it's quite an undertaking for a little mining company like us to take this thing on, but we're very happy to do it. You can see there's over 3,000 strings of panels here on 276 inverters involved here. The trackers are out of the U.S. by Array Technologies. Again, over 1,100 trackers, about 90 meters long each. And so you can see this area. It's just it's a huge plant. Battery systems will be supplied by Wärtsilä. We've finally got that in. They're just because of the types, the exact style and everything, we went a little bigger. Originally, we were talking about 3.5 megawatts of battery storage. So this is a little over that. These are just a little bit bigger than that. But these batteries. We can have like 3 engines fail or 2 engines fail completely, and the battery can pick it up. It can pick it up it can put out about 17 megs of power for about 45 minutes. That's full draw. For little bumps, if we need a little more power, if we want to start a mill, start the mill. The battery will pick it up. We don't have to bring another engine online to be able to start our SAG mill, for example. Things of that nature. So these are some of the benefits of that battery just taking out basically all of the spikes here. Again, we briefly mentioned this, but the integration of all of these systems is the key thing here. I know some solar plants have been set up to where let's say the non-essential equipment will be tied to the solar panels. The essential equipment is tied to the engines over here, which they feel you have more control over this. Because we've gone to such a big scale, there's just no potential to do that here. We're looking at producing, on a good day, 30 megawatts of our power out of 40 is coming from solar during the daytime hours. So it has to be fully integrated into the control systems to where you're running your main equipment right off of this thing. And again, what's your insurance policy here? It's what I call it. It's the batteries. It's the batteries that help you do this. So if you want to start a mill, start it up. If you have some cloud cover coming over that's only going to last for 20 or 30 minutes, it's going to drop your PV production, no problem. Battery will pick it up. If your batteries are fully charged, let's say at the end of night shift and you see a clear day with the satellites are showing you got nothing but clear skies coming in the morning, maybe you run on batteries for a little while rather than you shut an engine down sooner. Go ahead and shut an engine down a little earlier. You're going to pick it up again when the sun comes up in 40 minutes or so, 50 minutes, things like that. So one of the key things here will be operator training to make all of this work. The goal is to shut off 3 engines a day. So we'll have 3 of these big engines down. They're 7.2 megawatts apiece. We'll have them idle during day shift. On a really good day, we may shut down 4. If this thing's putting out a full 30 megawatts, we may get 4 of those engines offline at times. So operator training is going to be absolutely critical. With the integrated systems here, they're going to have a lot of assistance. They're going to see when spikes can occur in the PV. They're going to have advanced warning of weather patterns, things of that nature. But we're actually upgrading in the powerhouse now. A couple of our lead operators now, it's going to be required that they're electrical engineers. They're not guys not just a guy with a little of electrical experience that we trained up to run this. No, we want really top quality people in here because we want to maximize the time that these engines are shut off. That's the goal here. Forecasting system, we touched on briefly, but again, 2 kinds. One is from the satellites, and it's giving you your long-term projections. It can look out there quite a number of hours to tell you what's coming. And then we actually have sky monitoring. So we'll see little local occurrences, little local clouds floating by, things like this. It's also going to quite help the operation of our little airport there too, by the way, but for the weather patterns. But and this all feeds back into the integrated system. And so the guys can plan. Well, wait a minute. We got some real storms coming through, so we're not going to shut down 3 engines. We're going to shut down 2 engines, or we're just going to shut down 1 engine, or whatever that may be. But they'll know that ahead of time. They'll know, it'll give them a planning tool to be able to know how to best utilize the system here. So what do we get out of this? Why did we do this project? Why did we take it on? And by the way, we looked at, one of the things we looked at doing this a whole bunch of different ways. We looked at an EP plan, which is engineering procurement, and that's what we went with. Our SunTrace guys, combined with BayWa, by the way, they have a bigger company they're working with now jointly to give them a little more capacity in some of these areas. And but with SunTrace and BayWa combined, they went through, sorted out all this stuff for us, and they made the recommendations. We're doing the purchasing. We're building the plant, but they're going to come on site and help us with make sure the thing is constructed in a very proper manner, and then help us get through startup and training and make sure that this thing is running exactly as it is. Again, we're not electrical experts. We're not solar experts. So we've gone outside for that expertise to help us. But again, we get to shut down 3 generators on average every day. We'll save over almost 13 million liters of fuel, a little over that is the projection, hopefully a little more. That's about a truck a day. It's a semi-load of fuel a day almost. I think I figured that out to be like 290 trucks or something like that per day. So that's a big savings. We'll produce over 63,000 megawatt hours of power per year. About 39,000 tons of CO2 is what this saves out of that 13 million liters. The way we've got it projected now, solar make up about 18% of our total power requirement. Most days you're only going to have solar around 8 hours, so it's that plus it's not the full load, so it comes in right around that. Hopefully we'll push that up with operator training and get that a little closer to 20%. That's the goals we'll be shooting for. It reduces our processing cost by 7% overall. Again, makes money. Things makes money for us. Cost savings of $9 million a year in that range. The total capital cost of this is about $38 million. It would have been more than double that 5 years ago. That's how the price of panels and batteries, inverters, everything is coming down. I guess the technology is getting paid for. Everything's more efficient also. Batteries are more efficient, panels are more efficient. You don't need quite as many of them. So it really, the economics of this stuff is really starting to work. And we mentioned earlier on the panel, a payback for this project is right around 4 years, which is a very, very comfortable investment for us. So why isn't everybody doing it, I guess is my question. It also helps us with the operation of our engines. We can service engines during daylight hours. We can shut down enough engines to where our plant's split kind of in 2 halves with a general area and offices kind of in the middle. Servicing an engine with the engine next door running full steam, it's noisy. It's not a very nice environment to work on things. We can plan this to run engines just on one end of our plant now and do all of our servicing in a nice, quiet, clean atmosphere now. We can stagger the engine life more. We can stagger our hours a lot better on our machines for doing overhauls to make sure that all of our engines don't, it's 15,000 hours. We've got to do all this maintenance on all of our engines in the next 3 months. Well, we can stagger our running hours much better and use the solar plant as a means to do that. So the maintenance and service of our existing engines can take another notch up, and we can plan it much better, and we can handle that much better because of the solar. So that's one thing that we're really looking forward to. We're looking at, of course, I told you we're expanding Fecola to 7.5 million tons. We're looking at, we have a project called Anaconda, not too far north of Fecola, which we're drilling on. We call it the snakes. We have the Mamba deposit, the Anaconda deposit, the Cobra deposit, the Adder deposit. So the snake pit north of us is turning out. We're getting some very encouraging results up there, et cetera. What would we do for power for that? Well, we'd probably run power lines from our existing power plant at Fecola. It's about 20 kilometers, 25 kilometers north of us is all it is. So we'd probably run power up there. Well, do we have enough power? Well, maybe not. But we do have the potential to expand this solar plant also. It's basically a plug and play. These batteries come in containerized units, things like that, adding additional strings to this thing, more inverters, things like that. We can add another 10 megawatts. We could probably add more. It's all space, just make the space available and do it in a common way. So the solar plant gives us that flexibility. So that's about, we're very happy we took this on. We took it on to build it ourselves. We're kind of an outlier in the industry. We build our own plants. We do our own mining. We like to have, I don't know, maybe we're control freaks. I don't know, but we like to have our hands on it. If something's not working, we like to be able to grab it and fix it. We don't find we can do that through contractors. We do use contractors. Fecola plant was designed by Lycopodium out of Brisbane. We worked with them on a number of plants, but the execution of the construction is our own people. And so we've taken on that same concept for the solar plant. The execution of the construction is our own people. Yes, we're using some subcontractors to do various things, but it's under our direction. So we're doing the plant in that manner, similar to the way we basically build everything. So that's basically it. Trying to keep on the timelines here so Adrian doesn't come up here and slap me. Questions? After? Okay. All right.